In this video, we will learn the concept of Azure Kubernetes Service. We have already discussed what Kubernetes is and its architecture on the first section of this lesson. Now we are going to discuss Kubernetes integrated with Azure Kubernetes Service. You can deploy Kubernetes without AKS on-premise with all of the components are on the local resources. However, AKS provide a managed service that reduce the complexity of the deployment and core management tasks. See the image on the slide. On the previous discussion, we have mentioned that the desired state must be described first by creating the object that would be used for the deployment. For the API object creation, it is still being done using PowerShell, and after doing so, the created object would be seen on the Azure portal. Just like on Kubernetes, the Azure Managed Cluster Master have the API server along with the three process that makes Kubernetes communicate with the nodes. Kube API server is how the underlying Kubernetes API are exposed. This component provides the interaction for management tools such as kubectl on the Kubernetes dashboard. etcd maintains the state of your Kubernetes cluster and configuration. It's a highly available key values that store within Kubernetes. Kube Scheduler. When you create or scale application, the scheduler determines what nodes can run the workload and start them, making this the main component of the cluster master for distributing workloads, communicating with the nodes. Kube Controller Manager. A controller manager oversees a number of smaller controllers that performs actions such as replicating pods and handling node operations. As you all know, to be able to run your application and services, you need several nodes to process the workloads. So here are the example of customer managed nodes: the Cubelet, the container runtime, container, and kube proxy. If you still remember, Cubelet is the one responsible for receiving and distribution within the node of the received workload from the cluster master scheduler. Let's define each customer managed node. Container runtime is the one responsible for the execution on the managing of the containers inside the node. In our case, we use Docker to be our container runtime, run our Kubernetes pod. So before you start your big data, make sure that you have a container runtime that would run and manage your pod's container. Also, if you are using a virtual machine to deploy this, make sure that it is configured to allow nested virtualization. AKS uses Moby, which is also launched by Docker. The container would allow us to store the image of our desired environment. You can create the container using the Azure portal or the command prompt, AZ create command line. After the creation, you need the container runtime that we have mentioned to use it. Finally, the kube proxy. So this is the code, okay? So the virtual networking for the pods to connect to each other is being handled by the kube proxy. The proxy routes network traffic and manage IP addressing for services and pods.